Alright, we're going to do something called a literal equation. Literal equations are equations that don't have many numbers or any numbers in some cases. So here we go. Literal equations are equations that contain two or more variables. There are many literal equations in the form of math, science, and engineering. Right? These formulas seem like they can only be solved for the variable that is isolated on one side by using inverse operations and the properties of equality, all of which we've talked about. A formula can be arranged so any variable in the formula is isolated. It is no different than how equations are solved using inverse properties or inverse operations with the properties of equality. So this is not a literal equation, right? 42 equals 6x is not a literal equation, but if I was going to solve for x, what I would do is I would divide by 6 and I would get 7 equals x, right? The reason for dividing? Well, the problem says 6 times x, right? Dividing is the inverse operation, right? We have that inverse operation that allows us to divide. Why do we divide by 6? Right? Well, to remove the 6, right? If I was dividing by something else, it would remove another number. That said, those are the essential questions here. How do we move something? We do the inverse operation. How do we move it? We divide by it. If I want to move 6, I divide by 6, right? So keeping that in mind, we're going to come down here. This is a rectangular prism. The formula for a rectangular prism is, well, V base equals VH, or, here we go, all right, volume equals length times width times height. It's a literal equation. V represents volume, L is length, W represents width, and H represents height. Using inverse operations, the formula can rearrange to solve for any one of those variables. All right. Like solving for x, a formula can rearrange to isolate a variable. So if we look at this, in the formula V equals LWH, the variable H needs to be isolated. So you know what I divide by? I divide by the other two. I divide by LW. I divide by LW. And these cross off over here, and I got H equals volume divided by LW. I should put a W more like that. So what do we use? The operation of division needs to be used, right? The inverse operation, right? Oh, the operation of multiplication is used in the formula, and the inverse operation of division is used to isolate H, and that's literally it. If you look down here, use the formula for a rectangular prism, rewrite the formula to solve for L. So here we go. Volume equals length times width times height. Hold on one second. Can I call you right back? All right. Bye. So I'm going to solve for L by dividing by WH. By dividing by WH. And these guys cross off. And I get volume divided by WH is equal to length. Literal equation. Alright. So, if you look at these guys, let's do a couple more. Alright, using inverse operations to isolate unknown variables in a scientific formula. The formula for density, right? Density equals mass divided by volume, right? That's the formula for density. So here's how we have one, all right? The sinker on a fishing line is made of lead and has a volume of, that tells you the volume, 0.000015. What is the mass of the sinker, right? So the density formula can be arranged to isolate mass, right? The mass of the volume and the density can be used to substitute into the formula to find the mass. But first, we want to solve for mass, so let's isolate for mass. Look, this says mass divided by volume. Divided by, so the inverse multiplication, to move V away from M, inverse operation of multiplication, we multiply both sides by V, those cancel off, and I get this. I get density times volume is mass. And what do you know? They give us the density right here. They give us the volume right here. We multiply them together, we get our mass. Right? If you come down here, the design for a life preserver requires 0.03 kilograms of plastic. Alright, to provide buoyancy. What is the volume formula for plastic? I'm sorry, volume of the plastic foam required. Rearrange the density for volume now. Now this one's a little trickier, right? Because volume's on the bottom. To move it, I multiply by volume, right? Both sides, and now the volume comes off the bottom over here and appears on the top over here, which is where we want it. We want to solve for volume. But now it's sitting next to D. It's multiplied by density, so we divide by D. These cross off and volume is mass divided by density. Now substitute the given values. Well, let us see. Do we have it up there? Plastic foam, I think I see it up here. Plastic foam is written up here. It's 70, so the density of that, which goes on bottom, is 75 kilograms. And it says, or 75 kilograms per square meter, meter cubed, sorry, or cubic meter. And it looks like we've got 0.03 right there. And honestly, I'm going to leave it like that because I don't have a calculator on me. Alright. So, try to solve. You know what? Let's set one more up. And then I got to call my wife back. So here we go. For the altitudes up to 36,000 feet, the relationship between ground temperature and atmospheric temperature can be described by this formula. Alright? In which T is the atmospheric temperature in degrees Fahrenheit. A is the altitude, so let's find out what they are. Alright? In feet, at which atmospheric temperature is measured. And G is the ground temperature in degrees Fahrenheit. Determine the altitude, and then they say all of this. So we're going to determine the altitude. So we're going to solve for altitude. Alright? So I'm going to write it. I'm going to go T equals negative 0.0035 altitude plus G. So we want to solve for altitude. So we divide by G, or subtract G from both sides, because that's a plus. The inverse of addition's subtraction. And I get this. I get T minus G equals negative 0.0035 altitude. I still want to divide by altitude, so I divide by, I'm sorry, get the altitude by itself. So that says times, so I do the inverse operation. I go minus 0.0035. Alright, divide by a negative 0.0035. That's multiplication, so the inverse operation is division. What I get is this. I get altitude, because these cross off, is equal to T minus G divided by negative 0.0035. And then I plug everything in. So here we go. Altitude, excuse me, equals negative, what do we got? 27.5 minus, looks like G is 60, over negative 0.0035. I'm going to try that on my Siri real quick. Uh-oh. There we go. Siri, what's negative 27.5 minus 60?
That would be minus 87.5.
Siri, what is negative 87.5 divided by negative?
It's minus 175.
Siri, what's negative 87.5 divided by negative 35 10,000ths?
Let me think. Okay, I found this on the web. For Siri wants minus 87.5 divided by minus 3510,000s.
Alright. I don't have a calculator, and this isn't working out. But if I plug that in, that would be my answer. I'm going to pause this. Plug that in your calculator if you got one, by the way. Get the answer to this, and we'll talk about it. I am going to pause. We have one more page to do, and we'll get right back to it.